Picture this, a crimson orb hanging in the blackness of space. This is Mars, our celestial neighbor, a planet that has captivated the human imagination for millennia. But what if we could transform this alien world into something more familiar? What if we could make Mars our second home? This is the audacious dream of terraforming, the process of engineering a planet's environment to make it suitable for human life. Could we one day turn this cold, barren desert into a vibrant, living world? The answer lies in understanding both the immense challenges and the tantalizing possibilities that Mars presents. Terraforming is a concept that stretches the limits of human ingenuity. Imagine a future where we could walk freely on the surface of Mars, breathe the air without the need for spacesuits, and cultivate crops under an open sky. The significance of such an achievement extends far beyond simply expanding humanity's reach into the cosmos. Terraforming Mars would be a testament to the power of human innovation and a beacon of hope for the long-term survival of our species. Before we delve into the possibilities of transforming Mars, we must first understand the challenges it presents in its current state. Mars today is a stark and unforgiving world, a far cry from the lush, Earth-like planet often depicted in science fiction. Its atmosphere is incredibly thin, about 1% the density of Earth's, and composed primarily of carbon dioxide. This evidence of past water, combined with the detection of subsurface ice and the possibility of underground aquifers, has fueled scientific interest in the potential for Mars to harbor life, and the possibility of one day making it habitable for humans. One of the most critical challenges in terraforming Mars is creating a breathable atmosphere. The current Martian atmosphere is far too thin and lacks sufficient oxygen to support human life. One proposed method involves releasing greenhouse gases into the Martian atmosphere. These gases, such as carbon dioxide and methane, trap heat from the sun, warming the planet and thickening the atmosphere. This process, known as the greenhouse effect, is the same one responsible for maintaining Earth's habitable temperatures. Another, more ambitious proposal involves redirecting comets or asteroids rich in volatile compounds, such as ammonia and methane, to collide with Mars, releasing enormous amounts of greenhouse gases into the atmosphere. Water is the elixir of life, essential for all known forms of biology. Transforming Mars into a habitable world requires more than just a breathable atmosphere. It requires abundant, accessible liquid water. Vast reserves of water ice are locked away in the polar ice caps, and evidence suggests the presence of subsurface ice deposits scattered across the planet. One proposed method involves darkening the polar ice caps, for example, by spreading dark dust on their surface. Another approach involves harnessing the power of orbital mirrors to focus sunlight onto the polar regions, effectively baking the ice and releasing water vapor into the atmosphere. Additionally, there is the tantalizing possibility of vast aquifers of liquid water hidden deep beneath the Martian surface. Establishing a human presence on Mars is a necessary first step. This requires developing sustainable habitats that can protect inhabitants from the harsh Martian environment. Initial habitats will likely be self-contained structures designed to provide life support, shielding residents from radiation, extreme temperatures, and the thin atmosphere. As technology advances and the terraforming process takes hold, these habitats could gradually expand and integrate with the surrounding environment. Imagine greenhouses where genetically engineered crops thrive in Martian soil, powered by solar energy and irrigated with recycled water. The challenges of terraforming Mars are immense, requiring breakthroughs in engineering energy production and resource management. The timescales involved are also daunting, potentially spanning centuries or even millennia to achieve a truly Earth-like environment. One major hurdle is the development of technologies capable of operating reliably in the harsh Martian environment. Extreme temperatures, dust storms, and radiation all pose significant challenges to equipment and infrastructure. Additionally, transporting the necessary materials and equipment to Mars is a logistical nightmare, requiring innovative solutions for interplanetary travel and resource extraction. Solar power is abundant on Mars, but harnessing it on the scale required for terraforming will necessitate vast solar farms and advanced energy storage solutions. Beyond the technological challenges, terraforming Mars raises profound ethical questions. Do we have the right to fundamentally alter another planet, even if it is for the benefit of humanity. What if life, even in microbial form, exists on Mars? Would terraforming threaten its existence? Some argue that our duty to preserve life, including our own, compels us to explore all options for ensuring humanity's long-term survival, even if it means terraforming other worlds. Others contend that we have a moral obligation to protect the integrity of other planets, even if they are seemingly lifeless. If we succeed in terraforming Mars, the rewards would be immeasurable. Imagine a future where a second blue-green planet graces our solar system. Oceans teeming with life could reflect the light of two suns, while vast forests cover continents once barren and red. The creation of a biosphere on Mars is a monumental task, requiring the introduction of not just plant life but also a complex web of microorganisms, fungi, and animals. Picture sprawling nature preserves where Earth plants and animals coexist with new, Martian life forms, creating a unique and diverse ecosystem unlike anything found on our home planet. The journey to terraform Mars has already begun, albeit in its infancy. NASA, SpaceX, and other space agencies worldwide are actively engaged in robotic exploration of the red planet, laying the groundwork for future human missions. Rovers like Curiosity and Perseverance are tirelessly exploring the Martian surface, collecting valuable data about its geology, climate, and potential resources. SpaceX, with its ambitious Starship program, aims to establish a permanent human presence on Mars within the coming decades, a crucial step towards the long-term goal of transforming the planet. Terraforming Mars is a bold and audacious vision, a testament to the boundless potential of human ambition and ingenuity. It is a project fraught with challenges, uncertainties, and ethical dilemmas, a venture that will test the limits of our technological prowess and our moral compass. Yet, the allure of Mars persists. It represents a second chance for humanity, an opportunity to learn from the mistakes that have plagued our own planet and create a new home among the stars. As we gaze up at the red planet shimmering in the night sky, we are left with a profound question. What will our legacy on Mars be? The future of Mars, and perhaps even the future of humanity, hangs in the balance. What will we choose? If you enjoyed this journey to Mars, don't forget to like, comment, and subscribe to our channel for more fascinating content. Your support helps us bring you more incredible stories from the cosmos.